It's the truth. Scientists have finally discovered the first exoplanet. If exoplanets possess components that could allow them to support life, they could provide a new home for humanity billions of kilometers from Earth. It isn't easy to find exoplanets, so it's exciting when researchers finally get a direct view of an exoplanet. Exoplanets have been captured, but which one was it? And how did it get there? Learn how the first ever direct photograph of an exoplanet was ultimately acquired. What do you mean by the term exoplanets? Astronomers refer to planets outside our solar systems as exoplanets. NASA's Kepler Space Telescope has helped identify thousands of new exoplanets during the last 2 decades. Size and orbital patterns vary widely among these worlds. Some planets are huge, orbiting their parent stars closely, while others are cold and rocky. It's not clear why NASA and other agencies are interested in a certain form of planet, the same size as Earth and orbits like a sun-like star in the habitable zone. The habitable zone is the range of distances from a star where the temperature of a planet permits liquid water oceans, which are essential for life on Earth to exist in. Proxima Centauri, a star in the constellation Centaurus, may contain an Earth-like planet around it. Because it is 1.3 times heavier than Earth, the exoplanet Proxima b is likely made of rock. The planet is also located in the habitable zone of its host star at a distance of only 4.7 million miles, which is 7.5 million kilometers. Every 11.2 days it completes one orbit around the Earth. To put it another way, the exoplanet is most likely tied to the Earth's tidal cycle. To its star, it always presents the same face. Exoplanets weren't proven until the 1990s, even though scientists had suspected they existed for years prior because we can only see the moon's near side from Earth. Our sun and other stars like it spin at such a sluggish pace that they concluded, and they want you to know how our solar system began. Here's a quick rundown of the situation. The sun and planets were born as a whirling cloud of gas and dust known as the protostellar nebula collapsed under its gravity. While the sun comprises 99.8% of the solar system's mass, conservation of angular momentum dictated that the soon-to-be sun should have spun faster and faster. The planets hold 96% of the angular momentum. This disk of spinning gas from which planets formed would have had an extremely powerful magnetic field at its core. They were like anchors for the charged particles in the gas, slowing down the sun's spin while spitting forth the gas that would later become the planets. The sun and most other stars revolve very slowly, similar to the Earth's rotation. Consequently, astronomers determined that the same magnetic breakdown occurred for them, indicated that planet formation must have occurred. This implies that the presence of planets surrounding sun-like stars is rather prevalent. Planet 51 Pegasi were discovered in 1995 as the first confirmed world orbiting a sun-like star and are 20 times closer to its sun than we are. Your telescope can now capture images of any planet in our solar system. Astronomers have been able to discover exoplanets in various ways, one of which is that exoplanets are so far away from us that our telescopes have a hard time picking them out. Many options are open to you. The transit approach, which was used to find TRAPPIST-1, has yielded many exoplanets thus far. Small ground-based transiting planets and planetesimal telescopes are known as TRAPPISTs, were instrumental in revealing the presence of planets in this system. Since then, the extended Kepler project has discovered more with our primary planet hunting telescope, the space-based Kepler mission. This technique of transportation works well, so how? When the moon passes between the sun and the Earth during a solar eclipse, it is called a transit. Similarly to a total solar eclipse, where the sun's light dims from 100% to almost 0% brightness as seen from Earth before returning to 100% brightness after the eclipse has ended. When astronomers look for transiting exoplanets, a star's light may dim by only a few percent or fractions of a percent. Still, when the stars themselves dim by hundreds of times or thousands of times, it's impossible to tell whether or not an exoplanet is passing through. Exoplanets can be found by looking for dips in the star's brightness. Astronomers, on the other hand, had to create extremely sensitive instruments to make use of it. Because of this, scientists didn't discover exoplanets until the 1990s, despite searching for them for many years. However, keep in mind that you will only be able to prove the presence of an exoplanet this way. Doppler spectroscopy, often known as the radial velocity method or the wobble method, is the second most frequent approach for finding exoplanets. Wobbles are used for what purpose? As in all gravitationally bound systems containing stars, all objects in orbit revolve around a single center of mass. To detect a wobble in the star's center of mass, it is necessary for an exoplanet's mass to be large enough to alter the star's light frequencies. In the same way the sound of a race car's engine sounds high-pitched as the automobile nears you and low-pitched as the car moves away, this shift is a Doppler shift. Astronomers may believe a massive exoplanet is orbiting a star if they notice periodic shifts in its light spectrum. Others could then confirm the object's presence if they have similar equipment. For large exoplanets, the wobbling approach is only useful. Using this method, you won't be able to discover exoplanets since the wobble induced by Earth-sized planets is too small to be measured with existing detectors. Exoplanets are discovered using a technique called microlensing, which focuses on the detection of small dark objects. When objects in space bend space-time, light passing near them, scientists utilize a technique based on Einstein's general relativity, which is akin to optical refraction in some aspects. Putting a pencil in water causes it to appear shattered because the light refracts through its surface. The eminent astronomer Fritz Zwicky predicted as early as 1937 that galaxy clusters might be used as gravitational lenses. Even if the stars and planets in these clusters aren't very big, they aren't very good at bending light. One star must pass in front of another star much further away for exoplanet detection through microlensing. Therefore, astronomers may be able to tell the difference between an intervening star and its exoplanet by measuring the light from the distant source that the passing system has bent. Transit and wobble procedures fail to operate when the exoplanet is too far away from its star, but this method does. This strategy, on the other hand, is not particularly user-friendly. Direct imaging is the most difficult method for identifying exoplanets, but it is always the most difficult method. Technically, the exoplanets discovered by this method were first discovered through other means. Only afterwards, because of a combination of painfully hard effort, meticulous ingenuity, and breakthroughs in instrumentation, were photographs of the exoplanets obtained. Researchers have identified an exoplanet for the first time by utilizing a technique known as direct imaging. However, this new planet's strangeness doesn't end here. A few million years younger than the planets in our solar system, which originated some 4.5 billion years ago, is the newly discovered exoplanet 2M0437b, which is around the size of Jupiter and orbits a star 417 light-years away from Earth. 2M0437b is so young that the energy produced during its development has rendered it as hot as lava. The Subaru telescope was used to discover 2M0437b, and the instrument obtained an image of the planet illuminated by its star's reflected light. At the top of Hawaii's Monaca volcano, the 8.2-meter wide Subaru telescope, operated by Japan's National Astronomical Observatory, can provide astronomers with information about the planet's composition and how it evolved into a long-gone ring of gas and dust around its home star. Exoplanet 2M0437b is unique in that it can be observed up close and personal, unlike other worlds that can only be seen from afar. Visiting researcher Teriyaki Hirano from the University of Hawaii's Institute for Astronomy used the Subaru telescope to discover the planet for the first time in 2018. Baby exoplanets like this one are still a few million years old, which means that they still quite are warm from the strong planetary formation processes between 1400 and 1500 Kelvin. This means it can be detected at a distance of 417 light-years away, since it emits a faint infrared glow. The KEC-2 adaptive optics system, which considers atmospheric turbulence, and the Keck Observatory's near-infrared camera revealed that the planet is orbiting the parent star at a current distance of roughly 100 astronomical units. A single astronomical unit is approximately 93 million miles or 150 million kilometers in the distance from the Sun. Due to the parent star's slow motion in our sky, it took 3 years to confirm the Subaru observations as seen in the timeline. The James Webb Space Telescope in orbit will make it easier and faster to confirm the existence of exoplanets like 2M0437b and provide more information about the exoplanet, including its atmosphere and the possibility of a surrounding disk that could form moons. Let us know what you think in the comment section below.